show you some code.
All right, so at this point, now you should know how to begin building your overlay and start overlaying customizations on top of foundation code. So this is all well and good. You can go ahead and basically customize any part of the program by just copying your version of the file over the foundation version of the file. But after you do this for a while, you realize there are a few caveats to using overlays. One thing is you're at risk for a large amount of code bloat because you have to duplicate every file that you want to modify from the foundation project. And what this ends up, the problem this ends up creating is that when your underlying WAR file for the foundation changes, say from KC 3.1 to KC 4.0, any file that you've copied in there contains 3.1 code to your customized project. So if the underlying version changes, you need to check every file that you've copied in. This is mainly for Java code. You can do this a little more cleanly with other resources. But because it does a binary diff when it's copying Java code over the foundation code, it requires a lot more maintenance when version upgrades happen. So really the bottom line is that while overlays can do a lot of amazing, powerful things and are basically required for doing a good job customizing a foundation project, they don't replace the need for good coding practices and trying to make sure that your overlay project is as maintainable as possible. So one way that you can offload a lot of this work from the overlay and do things a little more cleanly is using the Spring framework. So what the Spring framework is a dependency injection, or one part of it is dependency injection, which allows you to encapsulate Java classes into beans. And this way you can wire up dependencies between beans without the Java code itself having to know about its dependencies. So what this allows you to do is you can change a lot of these dependencies and wire in new pieces of Java code using XML rather than having to compile it all through Java. So the way that this is set up in KC, because we are going to kind of focus on KC for the most part, although Rice uses the same type of framework, is it has classes called module configurers. And there's a separate one for each module. So in KC, you have an award configurer, you have a proposal development configurer, etc. And they each have a list of XML configuration files that they load upon startup. So award would have its own Spring Beans, its own data dictionary files, its own OJV mappings to the database or whatever sort of database mapping software you use. And then there are actually foundation provided hooks using the Rice whichever module you want to configure additional Spring files properties in your configuration XML. So to give you just an overview of how this is set up, kind of the entry point to your web app is through web.xml. Specifically, KC has a list of these beans called KC Bootstrap Spring Beans.xml, which points to the different Java configuration classes. For this example, we'll just focus on award configurer because they all are configured kind of similarly. But then that points to the individual Spring Beans, which contain your services and your standalone beans that KC uses to accomplish all of its work. Then you also have your configuration XML. This is where you define properties that are specific to your distribution or your environment. And one of these files you can have, or one of the properties you can have, is the additional Spring Bean file. So in this case, we can change dynamically which XML we're loading in on startup through the rice.kc.award.additional Spring files property. So, for example, in our use case, we just have an additional file called custom award Spring Beans that contains anything we want to override or customize from the original award Spring Beans. And one thing to note is if you're running a KC 3.1 or any pre-4.0 installation and you have no idea what I'm talking about, that's because this was a major change that happened between 3.1 and 4.0. Before, you could just put any XML you wanted to override directly into your web XML. But now, because there are separate award configurers, the change that happens is that each configurer has its own class path and loads its own Spring files. So therefore, if you want to customize an award Spring Bean, you need to make sure that you are hooking into that award configurer, because if you try to override it on a different configurer just from the web XML, it will actually be on a separate class path and you'll end up with two versions of the same bean. So that's just something to be aware of because a lot of people get tripped up on that on the upgrade. So I'm just going to run real quickly through some code samples so you can kind of see what I was talking about in that previous diagram. This is just KC Bootstrap SpringBeans.xml. You can see it just lists each configurer in the KC module. So if we take a look at award configurer again, you see that it has just these defined lists of Spring Beans that it loads. And you can't see it here, but because it extends that abstract configurer, that it contains a hook that looks for the associated KC or rice.kc.award.additional Spring files property. So here's a snippet from I use KC config custom, which is our specific config. And you can see these are actually provided by, because we have a separate Rice team, these are provided by the Rice team Spring files that they have overridden. And you can see for each module, KRMS, KSV, KIM, Q, etc., we have extra Spring Beans that we've made some modifications to. And the same goes for KC. You can see we actually have a lot of different files for the core Spring Beans because things like IRB and committees are actually hooked into the core configurer. They don't have their own configurer. So that's something to watch out for. We just have done it this way so that it's a little more easy to read and maintainable.
Jeff, can I ask a question?
Absolutely.
Sorry. So you are overriding QEMU and Q services earlier, right? So, but you're running a central Rice server. So are you just changing it for KFS and KC, the KIM and the Q services that you overriding?
Well, so yeah, we run an embedded installation, so we actually run against a standalone Rice server. And the reason that we have to do these overrides is because our Rice team provides a customized IU version of all the Rice jars.
Right.
So they've changed interfaces and things like that of
So
services.
that's what so basically KC and KFS both agreed that we wanted this.
Yes, so this is basically the way that this is actually a little outdated because the way that new projects do this now is Rice provides a baseline default config with all of these Spring Beans already mapped in, so that you don't actually have to do that. So,
I was just curious if we were doing it all over.
right, so yeah. So one example that I wanted to take you through just to kind of show how this works in practice is one change that we had requested from our award functional users is when we use award hierarchy. Currently, there's no really easy way to tell which level in a hierarchy you are in an award because there's a root level, a second level, and a third level. And so what they wanted to do was make a change so that each award number would have an A, B, or C level for the first, second, or third hierarchy level, so that you can tell at a glance what level of hierarchy you're in. And this turns out to actually be a pretty sweeping change across the application because award numbers are used everywhere. So it's a good case study for how all of these techniques can be used in one enhancement. So first off, and one example, and this is only a small part of the enhancement, of course, but you need to override